Today we're here to discuss the process of data cleansing, and we're going to use the 311 service records as our data source. As always, during these presentations, if you have questions or comments, please enter them in the chat box, and I'll try to make sure we periodically pause to address any questions that may be pertinent throughout the presentation. And full disclosure, I did used to work for DoIT, which is now the Office of Technology Innovation. And one of the projects that I worked on was the upgrade of the software for the 311 system. And that went live in 2019. So this presentation is designed to illustrate some basic principles and straightforward methods of data cleansing. The idea being that before you do any analysis, one thing you have to do is ensure that the data is clean, because it's probably not. And there are probably anomalies and misrepresentation of certain data points that need cleaning before you can do any analysis. It's a somewhat tedious task. It often takes longer than the actual analysis itself. And because of the intricate nature of the actual data you're working with, if you don't do data cleansing, you can end up with some invalid conclusions, which sort of taints the whole analysis. And we'll see a couple of examples of those throughout this presentation. And additionally, data cleansing, it's almost always unique to the particular data set, and so it's not typically scalable, and that kind of makes it hard and not such a fun thing to do, but it's one of the things you need to do. We chose to use the 311 service record data on the Open Data platform. It's really a terrific source of information. For one thing, there's lots of it, and it goes back a long time. In fact, the growth has been almost 50% over the last 10 years. It's also a remarkable data set in that it really gives a full insight into life and many aspects of life in the city of New York. And the 311 SR data set is the most downloaded data set on the Open Data portal. One of the challenges is that the daily data for this 10-year, this is a 10-year look. We're going to use 2 years for the actual analysis, but it's got lots of up and downs, and I wanted to sort of illustrate this. There's all the way for the low over 10 years on Christmas of 2014, which was just under 3,000, all the way to the all-time high over the last 2 years, which was on August 4th, just over 24,000. I actually checked the newspaper to see if there was something going on August 4th or August 3rd or August 5th, but I really didn't find anything to indicate why it would be so high. But it was during the pandemic, and as you can see, there's almost a tenfold increase between the highs and lows in the data. I want to take just one moment to thank my good friend Vidya Shanmugam. She led the performance testing team for the 311 software in 2019. And I can assure you, without her and her team's involvement, that spike of 24,000 SRs in a single day would not have been able to be managed by the previous software. So for this study, we're actually using service requests for 2 years, 2022, January of 2022 through the end of December 2023. And that data contains 47 columns. It represents input from 16 different agencies, and there's 210 different complaint types. The data set has about 6.4 million rows, and it comes from various channels to feed the actual data set that you download. I want to just briefly show those who may not be familiar with the Open Data portal. It's super easy to get this data out. All you have to do is search for the 311 service request. The data set will come up, and then you go to this little query data menu that's over on the right, and you hit actions. That drops you in a screen where you can filter on some field, and the field you usually want to use is created date, and you can select those and select apply, and out comes the data. In our case, we decided to actually export the data because it's a pretty large data set, and then analyze it in a custom written R program. So this is what the monthly data looks for the analysis. Um, Not a lot to see here. You can see a little seasonal effects. This typically happens to where the volume is a little lower in the winter and spring months, and then it sort of peaks in the summer and early fall months. But the daily data, again, is still quite noisy, all the way from the low of Thanksgiving in 2022 to a high in late September of 2023. By the way, the median number throughout all this was about 8,800 311 SRs per day. The data is lopsided in terms of which agencies are involved. We often refer to the big six: NYPD, HPD, Disney, Transportation, Environmental Protection, and Parks and Rec. Those six agencies make up 90% of the SRs that are here, within NYPD clearly leading the pack. And there's other agencies that are represented, and they have small percentages. But let me point out that even a small percentage of a nearly 6.5 million record data set is still a pretty significant number, and it's still pretty darn useful for doing analysis. Just another little quick background here. Here's the top 20 complaints of complaint types. I pointed out on the screen here with the little red arrows that there's 8 different types of noise complaints. So I'll show you, if you add them all up, they really constitute the most number of complaints. But illegal parking, hot water, those sort of line up with the top ones. And here's exactly what the top 5 complaints are. Noise makes up nearly a quarter of the complaints. There's 8 different types. I think noise park is a little unusual. Like, yeah, parks are outdoors. And noise house of worship, that's some enthusiastic people, I guess. Illegal parking, health and heat and hot water. You can see that these probably go to NYPD. Heat and hot water go to HPD. Blocked driveway goes to NYPD. Unsanitary condition, those complaints, of course, go to Department of Sanitation. Okay, and just for fun, here's the ones that have the fewest complaints. And by fewest complaints, I mean the absolute 1 or 2 or 3 complaints out of 6.4 million. So here they are: trans fat, tanning, and tattooing. So we got some real body shaming, I think, going on there. There's only one unlicensed dog, which sort of surprises me. One of the low one, quality of life. I'm not sure what 311 is supposed to do about that. And believe it or not, there's actually total of three compliments for the New York City taxi. And of course, my favorite, all-time favorite, radioactive material. I don't want to know. So we'll jump on. Let's get to the meat of the matter. What do we want to check for when we're doing analysis? Well, we want to, and this presentation is really all about identifying the dirty data, not really fixing it. But if you can identify data that you know is irrelevant or inaccurately recorded, then you can make a decision whether to include it or exclude it in the analysis that you're working. And we're going to look through 6 basic areas today. First of all, structural issues. Is the data in the expected format? Then we'll look at missing or blank data. I mean, if the data is not there, you can't do very much analysis on it. And then we'll look to see if the data fields actually contain the correct data type. Are numeric fields actually numbers? And then we'll look for invalid values. I mean, the simplest example is, there's only 5 boroughs. So if one of the boroughs is Larchmont, no, that doesn't count. That's an invalid value. And there's some logical inconsistencies that we'll touch on. They're kind of interesting. There's some concerning patterns that you need to pay attention to. And last but not least, there's some redundant columns, and we'll see that as we go through this. So structural issues. So a brief overview of sort of what this SR data looks like when you download it. Well, there's 4 date fields: created, closed, an updated date, and a due date. Almost none of the due dates are filled in. Surprising. There's 3 borough fields, 2 of which are complete duplicates. There's 2 zip code fields. One of those zip code fields as we'll see, has a lot of invalid values. There are 7 street fields, 2 pair of which are near duplicates. Those are cross street and intersection street. There's agency abbreviation and there's agency formal name. There's 2 police precinct fields, both precinct, singular, and precincts, plural. And unfortunately, they're not duplicates. And then there are 6 computed fields at the end of the data set, which we'll talk a little about in depth. And those 6 computed fields have some validity issues. And then in addition to street, there are 3 other location-related fields. There's latitude, longitude. There's a field called location. There's a field called XY state plane, which is a mapping system used for the state of New York. And then there's a very discrete location methodology that New York City uses, which is called block number. So I mentioned that there's some unusual fields in the data set. These are the computed fields. The data dictionary defines 41 columns. You can download that in the portal. But when you extract the data, there's actually 47 columns. Okay, so what are those extra 6 columns? Well, it turns out they're computed fields, and I'll show you what that means in a second. They're displayed as computed in the Open Data portal, but they're not in the data dictionary. And these 6 fields are zip codes, community districts, that relates to community boards, borough boundaries, city council districts, police precincts, and police precinct. And so the question really is, what are the validity of some of the validity of these computed fields? So if you actually go in the portal, there's something called Column Manager. You can select which columns you want to export. Yeah, I think it defaults to all columns, but you don't have to do that. And there's a little icon here, and you can see it's got little columns over here, and that should be a dead clue. If you click on that, it lets you select. And at the end of the data set, there's these 6 fields, and you can see that they all have this little notation: computed, computed, computed. So that's something that's a little structural anomaly that we didn't expect to encounter, and we'll talk about the validities of these fields when we get down to that section. Okay, let me check the checkbox right here. Yes, that is true that most noise complaints do tend to weigh towards NYPD, and most of those noise complaints are referred to that agency. A few of them go to environmental protection, but the majority of them do go to NYPD. Radioactive material. Yeah, I'm not going to comment on the subway system of New York City. Well, yeah, comments on the Open Data website. Yeah, there's no real easy way to find accurate or misleading data. There is an updated field that shows how often and how lately the data was updated. There are a number, I think, of comments and corrections you can make to the data. In fact, Saquana, I would encourage you to actually submit some of these questions to the Open Data team. I found they're pretty responsive to input from the users to look into or correct or perhaps consider altering some of the data and how it might be used. And what's the difference between police precincts and police precinct? I'm not sure I know. A police station is not a police district. Okay. Let's look at missing and blank data. 47 fields, 10 of those fields are mostly blank. Above 90% blank. It's still a lot out of a 6 million data set. 6 million record data set, but a number of those fields relate to taxi to TLC fields, pickup location, taxi company, and some other categories that look like they apply mostly to the Taxi and Limo Commission. And then there's a whole bunch of fields. There's several fields, 5 of them, that are kind of like mostly filled in, but with some blanks. Basically 30 to 40% of those fields are blank. But the majority of the fields, 32 of them, have almost no blanks, no, very small numbers, created date, closed dates, complaint type, agency, some of the big stuff that you want to add, that you want to analyze. And so that's pretty good. Um, So this is kind of how those columns line up in terms of what percentage they are of blank. Uh, so there's kind of the mostly blank. These round up to 1, but they're not really 1. They're 0.9999. And then there's these fields that have like some blanks, between 29 and 40% are blank. And then there's all these fields that have almost no blanks at all. So if you're doing your analysis and it involves some of these fields, well, you're in good luck. You got a plethora of data. And if you're in some of these other fields, you'll still have data and probably enough for good analysis, but it'll be far less than the actual number of rows that are in the data set. So that's where we are in terms of missing and blank data. So one of the questions and one of the things that we want to look at is, do the columns contain the correct type of data? Hint, yes, is the answer. And this is good news. It turns out that when we subject all of the columns to kind of a data type validation, that is, our number fields really numeric, or our character fields all character, or the date fields all dates, and absolutely almost all of them were compliant. We could only find 1 or 2, and those were typically in the date fields. But the missing data are really represented as NA, and that's okay. You can accommodate that. So that's kind of a good news story, that the data is all in a correct data type, and you don't really have to worry about that. However, there is this question of sort of valid data, and we did look at this. So generally, this is good. Good news. The latitude and longitudes, for example, are all within the north, south, east, west boundaries of New York City. That was pretty easy to check. And yeah, none of them are in Connecticut or New Jersey, God forbid. And all the unique keys are in fact unique. And most of the columns kind of have an implied domain of legal values. Address type, there's only a limited number of statuses. Of course, borough, there's only 5 choices. A few of the others, but most of the columns, even though it's not defined in the data dictionary, it's pretty easy to discern that there's sort of a set of legal values, a domain of legal values that they have. Let me take a moment just to look at the chat box here. Election zones, I don't know that. The submission for questions to the open data questions is, I believe, on the home page of the open data website, the opening home page. I believe kind of like down in the bottom of Contact Us, there's a pretty easy link, and it opens an email window that leads there. Is there a reason related to the data that might be blank or missing? That is an excellent question. I don't really know the answer. You'd have to look at the agencies that are responsible for those particular data, those particular columns in the data set that are responsible for that data, and sort of see there. Yeah, and again, yeah, give feedback to the open data team. They're pretty darn responsive and very interested in trying to make sure the data is the best and the most usable that they have. Okay, so let's look at some invalid data, which is sort of the next one on the list here. These are non-allowable values. So over half of this computed field zip codes are invalid. A whole bunch of those are zip code 1, 2, 3, 4, 5, not a valid zip code. A number of the police precincts, plural, are invalid. The other column, police precinct, singular, is almost completely valid. a small percentage, but still 27,000 of the community boards are invalid. And a number, even the high quality of the field called incident zip, there are still about 4,000 invalid values. And we check this against the actual USPS data set. There's over 44,000 valid zip codes in the United States. So it's a bunch, but data representation does have some challenges, and particularly when we looked at community district, we couldn't really evaluate, but we did note that there's 72 unique entries, but there's only 59 valid districts. So it's almost certain that, like 13 of those entries are invalid. And then as a final comment, sort of a curious thing, the latitude and longitude fields are captured as a 14 decimal field. That's really at the atomic level. So here's an actual latitude, North 40, a bunch of numbers. That last one there, 14 digits, is about 1 nanometer or 3 atoms. I know the geocoding is accurate, but I doubt if it's that accurate. So it's clearly a case where we have uh, uh, lots of precision, but limited accuracy. Um, so I just want to show you we do also do a breakout of the invalid fields. In this case, we're looking at that computed field zip codes where 58% of them were invalid. Well, you can see that that affects all the big six. In fact, they're right there in exactly the same order they were on the opening slide. NYPD, housing, Disney, transportation, environment, parks and rec. Well, that tends to indicate that this is a systemic issue, that it affects all the agencies involved in using the 311 system. I want to now do a quick case study. So where a noise complaint, here's a case study we just made up, but I think it's illustrative. So let's say the New York City Office of Nightlife wants to know what are the top 10 zip codes for noise complaints over the last 2 years. Kind of a relevant question given Mayor Adams' emphasis on nightlife and entertainment in the city. Okay, so how do you address this question? Well, you go to the portal, you select the 2022 to 2023 SRs where complaint type begins with noise. You select the zip code column, you aggregate by count, and there you go. There's the top 10 zip codes using the zip codes field to determine what they are in terms of noise, most number of noise complaints. Okay, what went wrong? Well, the problem is that now we know that 58% of those computed zip code fields are invalid. And so luckily the other, although somewhat weirdly named incident zip field is much more accurate. In fact, it's almost completely accurate. And this is a typical issue that you face with duplicate fields, which is which one is the right one. And so you can see here of the top 10 using zip codes, 6 of those, which is right at that percentage, 60%, 6 of those are invalid. Only 4 of them are true zip codes. And if you use the incident field, all of the top 10 are valid. The curious thing is that the numbers, 104,000, 104,000, these are almost exactly the same numbers in terms of the counts, but the zip codes are wildly different. So it tends to indicate that whatever computed activity is determining that zip codes, it's not working correctly. I mean, that's the obvious correction and the obvious conclusion, and really needs to be addressed. Anyway, so that's a quick case study. Let's go now look at the fifth data check, which is really inconsistent and unusual patterns. And we found a lot of challenges using dates. There are about 12,000 SRs that are service requests that are closed before they're created. That, I mean, that's obviously nonsensical, and it creates a negative duration, a response time that's in negative days. Some of these fields have a close date of 1/1/1900. Well, if you're an Excel fan, you know that that's the minimum date that Excel will accept. And it's also how in Excel interprets a blank field that has been denoted as a date field. So there's some concern that these closed before created came in from an Excel spreadsheet that was uploaded. But anyway, it results in like these absurd 100. It was closed. It was closed 122 years before it was opened. 12,000 of those. Perhaps worse than that, there's 200,000 that are created and closed at the exact same time, to the second. And those create another problem, which is a zero duration. And then another date-related question is there's about 7,500 SRs that are updated more than 30 days after they were closed. The actual field is called resolution action update date. I don't know if that's an error, but it does seem kind of strange. And again, we have some that are updated on January 1st, 1900. But even if you exclude those, some of the fields go as far out as 636 days after they were closed. Somebody is updating a record almost 2 years after it was closed. I don't know if that's an error, but it's kind of one of those, concerning patterns that we probably ought to look at. So let's take a look at how those break out by agencies. Closed before created. Well, there's one agency that makes up 95% of them, and unfortunately, it's transportation. So there are a few other agencies involved at very small numbers, but this tells us that essentially this is a Department of Transportation problem. And this idea of looking at closed and created date comes up a lot because one of the common things that people want to look at in the 311 data is how quickly are agencies responding to certain kinds of complaints. How long does it take sanitation to clean up trash on the sidewalk? How long does it take transportation to fix a stoplight that's out? And so these closed and created dates have a lot of value in terms of a lot of the analysis that goes on. And that's why having things like a zero duration or a negative duration are kind of troubling. Let me take just a quick look here at the chat box to see here. Community districts, these include joint interest areas, parts of serious jurisdiction. Okay, not technically community districts. That's good, and that's good information. Thanks, Stephen, for providing that information about the community districts, because my feeling is that kind of information would be very useful to include in the data dictionary so that people who are using the data have more information about what the data represents and what it includes and maybe what it doesn't include, that they're not technically the community districts. Cherry, thank you very much. I'm glad it's relevant. How are the computed fields computed? That is a question we're going to have to ask the open data team. I'm sure that they know about this. I think I've reported it to them. They're certainly aware of it, and I'm sure that they're working to try to see how they can be fixed or removed or at least documented in some fashion. Report noise complaints closed as soon as they're created. Phenomena that those of us who regularly use the C11 are familiar with. We love to know or see how this happens. I would love to know how it happens too. 311 has legal responsibilities to correspond to city complaints. They do. They have service level agreements with the various agencies as to how quick they'll respond, particularly for NYPD and some of the other agencies as well. That's absolutely right. And they're judged by that. This is public data, and of course, people hold them accountable for that. How am I getting this data? Data from the direct entry of the operators. D, that is a good question. The answer is a little of both. The 311 software that I was involved in implementing is used by the 311 call center. It also processes all the 311 requests that use the online app or the mobile app. However, there are 6 agencies that, for legacy reasons, have direct integration into the 311 system via APIs. And when we built the new software in 2018, 2019, one of our agreements with the agencies was that those existing APIs and integration points would not be altered in any way. So the new system had to be fully respectful of the integrations that had existed in the past. So I believe there's 6 or maybe 7 or 8 that bring data in sort of through the back door or through some other means. Like some of the data I think is actually imported. Like I think the transportation data comes through data analytics and then it's sent over to the 311 system. But that is an interesting point because not all the data goes through the same software. And here's the implication of that. I think Dee's aware of this. If it came through the software, we could impose certain kinds of limits and constraints and pick lists that would tend to ensure the data is valid. But sometimes when it comes through the back end and it's organic to another agency's systems, it's harder to do that. Well, let's take this close before created and do another quick Oh, I'm sorry. Here's a slide. This is called a violin chart that sort of shows the outliers. So these are all the negative durations. Okay, there's a whole bunch up here that are just a small number of days, maybe 5 or 10, but there's some real outliers here. 200, 300, 378 days closed over a year before the SR was created. That's a big negative data, and these outliers can really skew some of the data when you're trying to do things like averages. In some cases, using median is a better clue here, but the real question is, why are these negative durations actually happening, and what can we do to fix it? And from a data cleansing perspective, my thought is these are all invalid when you're trying to do analysis on the response time for a particular complaint type or a particular agencies. These are invalid SRs, and they should probably be completely eliminated from the data set before you go and do your analysis. That's how I see this kind of treated, but you do have to make a judgment, and in some cases you may have to find out, is there something else going on here you're not aware of? Like maybe the created dates are inaccurate, but still, I think they're just closed before they were created. In some cases, they're closed years before, and that tends to indicate a real problem here. All right, so here's an example of how that can be a problem. Okay, I think another fairly relevant question for today in New York City. Let's say the Department of Homeless Services wants to know how quickly are 311 calls for homeless person assistance, that's a complaint type, how quickly are those calls resolved? So, okay, let's filter the data by complaint type equal homeless assistance. You can do this right from the portal. It gives you about 75,000 SRs that are there during this 2-year period. And you can export those to Excel. That's easily manipulated in an Excel spreadsheet. And you can compute the duration, close date minus created date. Take an average of the duration field, and there's the answer. Well, if you do that, the answer comes up with almost negative 5 days. Well, how can that be? Well, it can't be. It's nonsensical. It makes no sense that the Department of Homeless Services is responding to these homeless person assistance SRs before they're actually created. And again, this is kind of interest for and sort of topical for today because, of course, there's a lot of discussion about whether professionals from the Department of Homeless Services should assist in homeless complaints, and most of them are usually handled by police. And there's a question as to how appropriate that is, and we're familiar with that discussion. So okay, that's what we're trying to resolve, is sort of this question: how quickly are they resolved? Okay, so as it turns out, there are only eight Department of Homeland Services SRs that have a close date of 1/1/1900, again, this Excel problem, I think, creates negative durations of 44,000 days. And that is enough, those 8 SRs with that huge negative duration, to distort the average duration and actually make it negative. By the way, I should point out that even in this example, the median is 0.2 days. But even if you remove the obvious incorrect close dates, these 1/1/1900, you still end up with an average of 1.7 days to respond to a homeless request. And the median, even under that, remains 0.2 days. So note that the median is 0.2 days. That's about 5 hours. And that value means that half of the homeless assistance requests are solved pretty rapidly. I mean, I think we'd be happy if the Department of Homeless Services, and I think they would be very happy knowing that over half of their requests are resolved in less than 5 hours. And so in this case, given the outliers, the median is the better descriptive in this case. And this is what this looks plotted on a typical violin chart. So here's these outliers, 113 days, and lots of other outliers. But look at the median. It's way back here. You can see all the thousands and thousands of points that plot way back here. This chart represents about 55,000 responses for homeless person assistance. So you can really see that the outliers influence the average, but the median probably tells a much better story here. And it turns out for homeless services, it's a pretty good story. Okay, let me take a quick look at the chat. Various data sources create inconsistencies. What tools are we using to do the analysis? There are a number of features on the Open Data website. We decided to export the data and make use of some of the capabilities in the R programming language. Of course, many of you know R is like heavily focused on statistical analysis. It's got lots of functions and features and packages that let you do that just bang right out of the chute. And it also has some really terrific graphic packages that let you do graphs like this and color them and do some things like that. If it's a smaller data set, and there's certainly a number of features that you could do the analysis right on the Open Data website. Yes, we talked about that. Yeah, noise complaints in the 311 set are their service level requirements. Okay, let me move on. So that's the outliers. Okay, so here's the SRs that are closed and created at the same time. They have a 0 duration. That's again kind of nonsensical. I mean, we're not talking about the same day. We're talking about down to the second that these are done. And these are not necessarily, you can see that it's 100, almost 100%, 99 with just 5 agencies, but they're not the big 6. Health and mental hygiene, transportation, yes, Department of Buildings, some agencies that we don't see so much in the overall complaint list, but in terms of 0 duration, they're the ones that show up and they're creating this problem. And in this data set for 2 years, there's almost 200,000 of these. And that can really distort again some of your analysis on response time and SLAs and things like that. So this is one I just want to show. This has to do with a kind of a logical inconsistency, which is the post-close resolution updates. I decided to use the 30-day cutoff. So if it's greater than 30 days after the SR was closed and then it was updated, I kind of want to catch that and I want to track that. And so there's about 7,000 of these that are greater than 30 days. And as you can see from this by agency histogram, they're almost all in TLC, Taxi and Limo Commission. So just like we were looking at one of the close before created was a transportation problem, this looks to be a TLC problem. And I say look to be because I don't know why the SRs would be updated more than 30 days after it was closed, but there might be some reasons. Now, having said that, here's a violin chart showing how far those outliers go. Here's the median, 9 days, 9.5 days. Okay, I got that. They're closed, and then a few days later, they do an update, a week later or something. But then there's a bunch of outliers here that are days, hundreds of days after the SR was closed. The extreme one, not counting the really extreme dates in 1900, 636 days after an SR was closed, it was updated. That's a lot of outliers out here that will really pull averages and standard deviations, far to the right of maybe where they should be to represent what's actually going on, which is closer to like nine days. Again, don't quite know why this is happening. And I think since it's a TLC issue for the majority, there really needs to be some analysis done, and you'd really have to reach out to TLC and kind of find out what's happening um, in those instances. Okay, let me just look on the chat box here. I guess it looks like we don't have any new ones. Okay, right. Okay, so let's look at the last item here. And we'll get through this fairly quickly. Let's look at some areas where there's redundant or duplicate columns. Well, there's a 100% match between Burrell and Park Burrell. Those are two different columns. That's redundant. There's nearly 100% match between a column called Burrell and Burrell boundaries. Now, there's another Burrell field called Taxi Company Burrell, and it has almost no matches to the Burrell field. So I don't know what's going on there. And 99% of the police precincts and police precinct are redundant. There's also a field called location, and it's a pure concatenation of latitude and longitude, completely redundant. So here's a latitude, here's a longitude, and then here's the location field right next to it in the database. So all they did was concatenate the two values, put a comma in there, and then add parentheses. One that's a little more troubling are these. We have Cross Street 1 and Intersection Street 1, Cross Street 2 and Intersection Street 2. And of course, anybody in New York knows that knowing the cross street is pretty important to sort of locate where something really is. The challenge here is that there's only an 88% match. And in some cases, one of these fields, like say Cross Street 1, will be blank, but Intersection Street 1 has a value in it. And the problem here is trust. Which of these fields do you trust when one of the almost duplicate fields differs or one is blank and the other is not? I don't have an answer to that, but I think our intent is to sort of call out what we see as some challenges here. All right, so this is kind of an overview of the problems that we've seen in the data set here. There's blank and missing fields. So really you have to ask the question, which fields are useful for the analysis? The duplicate fields not only make the analysis challenging because of this trust issue, but they also increase the file size for downloads and processing time. Some of our experiments showed that if we remove those duplicate fields, we could reduce the file size by 20%. Well, 20% matters when you're downloading a big file or trying to manipulate it in some sort of custom code. The invalid values will distort analysis if you're using any of those or most of those computed fields, zip codes, police precincts, community boards. And then the closed and create dates create these negative or zero distortions in the response time. So those have to be looked at and probably removed from the data set that you're working in. So some recommendations. Obviously, I think these are some of the things we see brought up in the chat box here. Many of these fixes lie over at the agency, not in the 311 organization per se. I think it would be useful to update the data dictionary to provide more clarity, to provide value domains, to provide, like that gentleman in the chat box, person in the chat box said, about the community districts. That information I think would be useful to include in the data dictionary, and we're happy to work on generating a draft for some review and things like that. Of course, review the fields that have high percentages of blanks or unknown values. Look to eliminate or discard or ignore the invalid values. And it would be great if we could eliminate them by incorporating drop downs, pick lists, field validation, and that particularly applies to the computed fields. And then there's, of course, also a possibility of putting some logical controls on selected fields, especially dates. Like you shouldn't be able to have a close date that happens before a create date. The software should sort of trap that. And sometimes that software, again, like point one, is back over at the agency. And then I think there's a real consideration that should be given to eliminate or consolidate some of the duplicate fields. Intersection, cross street, the 5 different borough fields, location, latitude, and longitude. And then there's this funky precision in the lat long fields that probably has to be addressed. Let me look at the chat box real quickly. What are the big 6 agencies? I referenced those on the first slide. NYPD, Housing Preservation and Development, Department of Sanitation, Transportation, Environmental Protection, and Parks and Rec. And those 6 agencies make up over 90% of the total number of SRs in the data set. So, if you want to clean up data and you can clean up those 6 agencies, you're going to affect a lot of the underlying data rows. Drop down. Let's see here. Yeah. Oh, yeah. You should attend that. You should attend that lecture on the School of Data. Martha's terrific. Gives a good presentation. Do you happen to know if everyone has a live API for data servers to get live data feeds? They do. I do know that. Yes, the answer is yes. They do have APIs. They're not exposed to the general public. You have to apply for permission and access to use the APIs. And you can, if you're doing routine data analysis and you're a legitimate source, I'm not sure what criteria they are, you can get access usually to the read-only APIs, and you can build applications that extract from that, and they're very useful. I wish every agency used the APIs, because when we built the system, we built in a lot of these logical controls into the APIs so that they would catch some of these illogical errors. Okay. Yeah, the 2 others are Parks and Rec and HPD. HPD and Parks, right. Sponsor limit to 1,000 rows. Oh, I didn't know that. Thanks very much. Yeah, you can get permission to use APIs beyond that. I'm pretty sure. Haven't worked with this for a while, but it requires a special application. You have to apply. You have to be reviewed and approved to do that. Okay. All right. So final thoughts. Data cleansing, it's a critical step. You need to do it before you begin your analysis. It largely determines which data fields can be trusted, which ones can be used. You need to evaluate them on sort of some of the criteria